Hello and welcome to Lesson 9-7. Today we're going to look at factoring special cases. Ultimately, we're going to look at factoring perfect square trinomials and the difference of squares. If you recall from Lesson 9-4, we actually looked at what perfect square trinomials were. And if you recall, we looked at the portion where we had a plus b times a plus b, and we looked at a minus b times a minus b. Okay, and what that did is that actually produced a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So what we want to do is now we want to be able to look at the trinomial, like this part here or here, and then be able to come up with these individual factors on our own. So to do this, we're going to first look at the perfect square trinomials. And in order to recognize that you have a perfect square trinomial, you need to look at the first and the last terms. So if we look at this example down below here, we can see that the first term, which is 4x squared, is a perfect square. Okay, and that's because if I take the square root of 4x squared, this is really going to give me 2x. My last term, 9, is also a perfect square because the square root of 9 is equal to 3. So that's going to meet my first set of criteria. Then my second set of criteria says that the middle term, or in this case the 12x, is twice the product of one factor from the first term and one factor from the second term. So in this case, when I take the square root of my first term, I have 2x, and if I multiply it by the square root of my last term, which is 3, and if I take this whole thing and I multiply it by 2 because it's twice that product, I hope that I come up with that middle term, because if I do, then this is a perfect square trinomial. So 2 times 2x is 4x times 3 is 12x. So because this 12x is the same as this 12x, I now know that I meet the second part of the criteria. So in order to factor this then, I'm going to end up with my a term is going to be the 2x, and because I have a plus here and a plus here, I know it's going to be 2x plus the square root of my last term, or 3, and I can either write this as 2x plus 3 times 2x plus 3, or I can say that that's really the same thing as saying 2x plus 3, the quantity squared. Either one of these are acceptable. Let's take a look at a few examples now. So for example 1, it says to factor, and the very first thing I do is I look to see if there's a common factor. 1, 8, and 16 do not have anything in common. So the next thing I look at is I look to see if my first and last terms are perfect squares. And x squared, if I take the square root of x squared, that does give me x, and the square root of 16 does give me 4. So these are perfect squares. So I'm going to take that 4, multiply it by x, and double it. And in this case, I end up with 8x. So I'm going to come back here, double check. It does work, so that's awesome because I know I have a perfect square trinomial. And I know that my first term then is just going to be x, and my last term will be 4. And then because I have this subtraction sign right here and the addition sign on the last term, that subtraction sign tells me that I really have to have an x minus 4. And again, I can write that as x minus 4 times x minus 4, or I can say that's the quantity of x minus 4 squared. For example 2, again, I'm going to look and see, do I have any common terms between the three terms? The answer is no. There's nothing that 9, 12, and 16 all have in common, but I am going to go ahead and double check and say, what is the square root of 9x squared? And I can see that that is 3x. The square root of 16 is 4. So I'm thinking or hoping that it might be a perfect square trinomial. So I take that 3x, I multiply it by 4, and then I double it. So this is going to give me 3x times 4 is 12, times another 2. This is going to give me 24. So because I do not have the same middle term as what I do here, this is not a perfect square trinomial. And this polynomial can also not be factored. Now when I look at example 3, 16, 40, and 25 do not have a common factor, but I'm going to check for my perfect squares. Square root of 16x squared is 4x. The square root of 25 is 5. So I'm going to take 4x, multiply it by 5, multiply it by 2. This is going to give me 40x, which just so happens to be my middle term, so that works out well. That's going to mean that my first term now is going to be 4x, and my last term is 5. This is a positive, and this middle term here is negative, so that tells me I'm going to have a negative. And I really have the quantity of 4x minus 5, and that will be squared, and that will be my final answer. Example 4, I can see right away that I have 5, 10, and 25, so I can factor a 5 out. This is going to leave me with x squared plus 2x plus 5. And if I want to try and see if this is a perfect square trinomial, the square root of x squared is x. The square root of 5 is, that's not a perfect square. So I'm done right there. If I want to look at factors and see if I can factor it, x and x are going to be my first set of numbers, and the only factors of 5 are going to be 5 and 1. Because both of them are positive, I need to have 2 pluses. However, when I go and I check my outside and my inside terms, I end up with x plus 5x, which is equal to 6x. 6x times the 5 that I have out up front is not going to give me the 10x that I needed to have for my middle term. So the only thing I can do to fully factor this is leave this as 5 times a quantity of x squared plus 2x plus 5, and this is fully factored at this point. Now, if you remember when we talked about special cases, we also had the difference of 2 squares. Okay, and what that looked like is that was when I had 2 binomials that were being multiplied by each other, and they had the same numbers, they just had a different sign in between them. So when this occurred, we ended up with a difference of 2 squared. So if you look numerically, something like x squared minus 81, because I have that negative in the middle, and x squared and x, or 81, are perfect squares, I can break that up into the difference of 2 squares. And we'll go ahead and look at a few examples with this. The one thing I cannot stress to you enough, though, is that in order for the difference of 2 squares to work, is you must have an actual difference. Okay? Difference meaning that it has to be a subtraction problem. Okay? If it's an addition problem of 2 perfect squares, it will not work. Okay? So the way this works is right away I notice that I have the difference of 2 terms. Okay? So what I'm going to do is I'm going to say, is x squared a perfect square? And it is. And then I say, is 9 a perfect square? When I square root it, I see that it is. So that means that I can write this as x plus 3 times a quantity of x minus 3. And now I have the difference of 2 squares. And this is how I factor that. Looking at example 5. Again, I see that I have an x squared minus a 64, so I've only got 2 terms. I'm going to double check that these 2 terms are indeed perfect squares. And because they are, then I know that this is going to be x plus 8 times x minus 8, and now I am done. With example number 6, I have 4x squared minus 16. So immediately I'm hoping that this is going to be the difference of 2 squares. However, I do need to factor out a 4 from both terms. So if I take a 4 out, I'm left with 4 times the quantity of x squared minus 4. And I still have a difference of 2 squares there, I'm hoping. But just to double check, I have the square root of x squared equals x. The square root of 4 equals 2. So if I pull my 4 down, I have 4 times, and then I have my x plus 2, and I have my x minus 2. And this would be the 3 factors for that binomial there. In example 7, again, I have 2 squares, or 2 terms that are being subtracted. There's not a common factor in between 9 and 49, so I'm just going to go and look and see if I can factor 9x squared, or sorry, if I can square root that, and I can. I can take the square root of 49, that gives me 7. So right away, I'm going to go and I'm going to say, well, this is 3x plus 7 and 3x minus 7, and now I'm done. And for my last example, I have 8x squared minus 50, so I have two terms that are being subtracted. I'm going to check and see if there's a common factor, and indeed there is. I can take a 2 out of both of these, and if I take a 2 out, I'm left with 4x squared minus 25. I still have the difference of two numbers, so I'm just going to double check and say, is 4x squared a perfect square? And it is, and the square root of 25 is 5. So that means that I can go ahead and I'm going to bring my 2 down because that's going to be part of the factors. And I have 2x plus 5 and 2x minus 5. And these are my factors. Please let me know if you have any questions. Otherwise, I hope you guys have a great day and we will see you in class.